Yes, now I do see your slides.
Okay, perfect. All right, thank you, Dimitri. Okay, so my name is Joe Dipol. I'm a member of the Helidon team, and I will be doing a presentation today on Eclipse MicroProfile with Helidon. If anyone saw Dimitri's presentation, there will be some overlap here, undoubtedly. But I will go ahead and do the presentation, and I'll be reviewing Eclipse MicroProfile a bit, talk a little bit about Helidon and Helidon MP, which is our MicroProfile support. I'll do a short demo and then leave time for questions if we have any. So Eclipse MicroProfile, this was an open source working group that launched in 2016. It defines a set of Java APIs for writing microservices. It started with a core set of Jakarta EE APIs, and then over the years has added new MicroProfile APIs. And the status today is that it's a fairly rich platform, fully functional for what you need for writing microservices. It's implemented by multiple vendors, so it is a kind of de facto standard of sorts. So you can select from different vendors that implement MicroProfile, and you can get more information at the Eclipse project there. MicroProfile is an Eclipse project. So that's MicroProfile. What is Helidon? So we provide a set of open source Java libraries for writing microservices available under Apache 2 license. We like to think that we're small and fun to program in. Helidon is cloud native ready, providing the basic capabilities you would expect of a microservices framework. In terms of a REST framework, support for metrics and health, etc. Our core server is Netty, so we are built on top of Netty. It provides our HTTP support. And what makes us a little unique is we have two programming flavors. You can choose from two different styles of APIs. Helidon Sc is kind of our core foundational API, and Helidon MP is our MicroProfile support. So here's a couple examples of the difference between Helidon SC and MP. SC is a small reactive framework, a very, very small footprint. You program in a fluent functional style. We like to think that it's very simple and transparent, very explicit. So you have an example of that code there. Here we're explicitly constructing a route so that any HTTP GET request to /hello will return the response hello world. And then we start up the server with that routing information and the server's ready to go. So that's kind of your smallest Helidon SE service. For Helidon MP, as we said, this is our MicroProfile support. We currently support MicroProfile 3.2. It also has a small footprint. And no application server here, just because it uses Java EE APIs does not imply an application server. So as expected, it follows more of a Java EE declarative style of programming. And in MicroProfile, you'll find familiar APIs like JAX-RS and CDI. And so kind of the smallest MicroProfile application is, of course, the JAX-RS application. And here we have our hello world class that's annotated with the path hello, and the get verb responds with hello world. So very familiar if you use JAX-RS style programming. So if you look at everything that's in Helidon MP, this covers a lot of what's in MicroProfile. So the blue boxes here are MicroProfile defined APIs. And as you see, they range from config and metrics to fault tolerance, as well as some new reactive messaging and stream operators. MicroProfile also has the Jakarta Api, so JAX-RS, or RESTful Web Services, JSON processing, binding, and CDI. In Helidon, we also have support for JPA, JTA, and Jakarta WebSockets. We've also can have some components that are unique to Helidon, and in 2.0 we added support for core support in Helidon. Currently, we're at MicroProfile 3.2. Our shipping version of Helidon is 2.0. And here we have a list of the MicroProfile spec version that includes. We are currently working on Helidon 2.1. That's set to release in the next week or two. And that will contain MicroProfile 3.3 support. So you can keep an eye out for that. So I'm just going to touch upon some of the MicroProfile APIs, give a brief description, and then I'll do a brief demo as well. So we'll start with config here. As expected, it's an extensible configuration system. You have a single view of your config that's fed by multiple config sources. So you can have sources that are Java property files, JSON files, LDAP directories, and Helidon ships with a number of data sources to support that. It is generally string-based, but with converters to Java types. And of course, you can use your config, you can inject your config as expected with these Java EE style APIs. So here we have a little example of code that uses config. So in this case, we have a property file defining some properties. And then in the application code, if I want to get that greeting piece of configuration, I can inject it. I specify the config property name, in this case app.greeting, and then that value of hello will be injected into my greeting variable here. So kind of what you would expect, but very flexible with the multiple data sources. Health check. This determines the health of your pod or computing node. Right, primarily health checks are used machine to machine, right? Kubernetes uses health probes to determine the health of a pod. And as expected, we have both liveliness and readiness probe support. So in Kubernetes, when it wants to see if a pod is alive, it probes a liveness endpoint. And if the pod is not alive, if that endpoint does not respond or responds with an error, then the pod is typically restarted. The other probe that Kubernetes often has is the readiness probe. And this is as a pod is coming up, the pod is alive, but then is the pod ready to accept requests? And that is what the readiness probe is used for. And so if the service is not ready, then for example, Kubernetes will not route requests to it until it is ready. Both of these are supported by MicroProfile Health Check through the liveliness and readiness annotations. And in the demo, I'll show a little example of that. MicroProfile metrics takes health and goes beyond that to let you get a view into what's happening in your application so you can monitor it. It splits up the metrics into base, vendor, and application specific. So you get some metrics out of the box, and then you can define your own that are application specific. It supports the metric types that you would expect, like counters and meters and timers. And it supports a JSON metrics format as well as open metrics, which is the Prometheus format. So out of the box, your MicroProfile application will work with Prometheus. So here's a simple example of MicroProfile metrics. In this case, we're defining a gauge called queue size, and then so it's annotated on the method that provides the size of the queue. Also, you can annotate methods in your service with @counted, and that will automatically create a counter for that method and count the number of times the method is invoked. So it's very simple to define these application-specific metrics. Moving on, we have tracing. Of course, this shows the big picture of your request flows, both within your application and across microservice boundaries. It supports open tracing and integrates that with JAX-RS, so that spans are automatically created for you for incoming and outgoing requests. And then in Helidon, we have support for both Jaeger and Zipkin for visualizing your tracing. So most folks are familiar with this. We see a little example here of an HTTP request that came into the translator front-end service. It was handled there, and then a call was made using the MicroProfile client, which our implementation is done via Jersey. So that's why you see Jersey there. That trace is then propagated onto the translator backend, which handles the request and then pops back. So overall, in this case, the full request took a second, of which, maybe about a little less than half of that was in the translator backend. So that's the tracing support. Fault tolerance, anyone familiar with Hystrix or other fault tolerance mechanisms will be familiar with the support here for fault tolerance. Obviously, if you're writing a distributed system, you need to have resiliency in your microservice. And so MicroProfile provides fault tolerance with the common mechanisms you would expect, like timeouts and retries, fallback, circuit breakers, etc. And again, it's done through a declarative style using annotations. So we see a simple example here of fault tolerance. In the first case, we have our method get stock quote. Maybe that invokes a remote service that could fail. And so we annotate this with retry, indicating that we want it retried a maximum of 2 times. And so if the stock quote method fails, it will be retried up to 2 times. And if it continues to fail, then here we have also defined a fallback. So this shows that you can combine these annotations to get the behavior you want. So if the retries continue to fail, then the fallback method will be called. And in this case, the fallback method simply returns maybe a cached value, like the last quote that was successfully retrieved. MicroProfile also supports a REST client. This is modeled after the JAX-RS REST client. And it's kind of a mirror, has mirror symmetry with the JAX-RS REST service. So you use the REST client by defining an interface. It's a typed interface that defines the interface onto your remote service. And then it proxies requests there. You invoke methods on the class, the type, and that results in endpoints being called on the remote service. So very familiar if you use the JAX-RS client. MicroProfile also supports Open API. This is exposed via endpoint / Open API by default. The Open API specification is generated for you automatically by examination of your REST resources, your REST endpoints in your application. You can also modify or influence this document via a programming model so that you can fully control what is exposed through the Open API specification. So those are kind of a number of the MicroProfile APIs. I'm going to touch a little bit here on how Helidon packages your application and how you run your application. As I mentioned, there is no application server here. Your application is simply packaged for you, and it is generally all self-contained. And we support 3 packaging forms. The first is a simple executable jar file. So this is a thin jar that defines a class path to its set of dependencies. So the jar file contains only your application code, and all the dependencies are kept in a separate directory and located through the class path in the jar file. And this is very Docker friendly because it separates your runtime dependencies from your application code. So we intentionally do not use a fat jar model here where everything is in one jar. Instead, we split it up into your application code, and then your runtime dependencies are separated on the file system. This makes it very friendly for Docker image layering. The second packaging we support is GraalVM native image. So this allows you to compile your Java application to a native binary, actually a native executable. So with this, you get obviously a very small disk footprint and very, very fast startup times. So there are some limitations with native image. There are some Java language features which don't work well with native image. But overall, for certain application types, native image is a big win. And with Helidon MP, you can take your MicroProfile application, and we've done a lot of the hard work to make it such that you can generate a native image from your MicroProfile service. And then the third packaging we support is JLink. So this supports building a custom Java runtime image that contains only the parts of the Java runtime you need. We also support generation of an optional CDS archive. That's class data sharing. This is an on-disk archive of an in-memory representation of your classes, so that at JVM startup, the CDS archive can be directly mapped into memory. So this improves startup speed for the JVM without any other compromises. And so this is an option for our JLink tooling that will produce a JLink image for you. And I'll show some of that in the demo. One thing we do have that's new in 2.0 is the Helidon CLI. This allows you to easily create a project using Helidon init. You can select from some various archetypes to create the project. And then we also have what we call the dev loop, which provides continuous compilation and restart of your application so that you start up the dev loop, and then as you modify your application, it is automatically recompiled, rebuilt, and restarted. And it supports modifying your source files or modifying property files. It detects all those and handles them. So I'll show a little bit of that in the demo as well. All right, so that's kind of the end of the presentation part. If you want to learn more about Helidon, you can go to helidon.io. We're also available on Medium. We have some YouTube videos. And of course, we're on GitHub because we're an open source project. All right, and with that, I'm going to switch to my demo. So I'm going to need to reshare my screen to do that. All right, sorry, I'm just trying to see how to reshare my screen. All right, I am back. At least I hope so. So what I'm going to do now is I'm going to start my demo. And I'm just doing this through some terminal windows, no IDE here. But the first thing you can do if you want to give Helidon a try is you download and install our CLI. So that's what I'll do here. You can just, using curl, you can get it off of helidon.io CLI latest. In this case, I'm grabbing the Linux binary. And then I can run Helidon version and see what version I'm running. Great, so that's installed. I'm now going to create a project. So I'll do that with Helidon init. I'm going to show a MicroProfile project. So I'll start with MP. I want the quick start. And then I will accept the defaults here. You can see at the end, it asks if it wanted me to start the development loop. I chose not to do that yet. I'll show that in a little bit. So now I'll just go into our project. And let's take a look to see what was generated for us. So here you can see the contents of the project. We have the POM file. As you would expect, this is a Maven project. We have some Docker files that we generate for you, so you can easily create a Docker image of your service. We also have a Kubernetes deployment YAML file if you want to deploy it. We have our actual application code. It's a pretty simple greeting service. And then we even have some tests. So let's go ahead and build it. And this will just take a second. So it's already built it, it's running the tests, and then copying the dependencies. So if we look what we have now, we have that thin jar file I mentioned. We're using our default packaging. And then if you look in the libs directory, you'll see the full set of runtime libraries required for this application. So these are all the runtime dependencies. Obviously, we'll find, open tracing, Netty, MicroProfile, Jersey, which we use for our JAX-RS implementation, Jakarta APIs, as well as Helidon libraries. So it's all there under libs. And therefore, to run this application, we can just run the jar file and it starts up. Okay, so let's see. What does this application do? It's really simple. It provides a greeting. So we have an endpoint /greet. And here we have a greeting, hello, Joe. As I've mentioned, we also have support here for metrics. And so I can get the metrics from this service. And this is, if you're familiar, it's Prometheus format for the metrics. That is good. We also have Open API support. So this provides the Open API document or specification for my service. So you can see here the greet endpoint and the response is JSON, as we showed. And also health. So here we have the health output. And as I mentioned, with health, you have liveness and readiness probes. So we can go ahead and just get the ready probe. This tells us if the service is ready, or of course, the liveliness probe. And you'll see for the liveness probe, we have some built-in checks that you can use that the system provides for you. So a deadlock check, disk space, and heat memory. And you'll notice in the ready probe here, it's just very simple, right? It's just responding that it's up. But maybe we want to add some a custom readiness check. So let's kind of see how we do that. So what I'll do, I'm going to stop my service, and then up here, I'm going to start the dev loop in the project. So as you see, it is building the project, starting up the server, and it's now waiting for changes. Okay, so here I am in the project. So I'm going to create a new readiness check. And so we'll do that the old-fashioned way using VI. And I have the code right here. So we'll take a look at this in a second, but as soon as I write the file, you'll see that the dev loop triggers a recompile and a restart. So now we can go ahead and ping that readiness endpoint, and you'll see now, previously the checks were empty, and now I have my custom check. So let's see how that custom check was written. So in the code, all I need to do is create a new readiness check that implements the health check API interface. I annotate it with readiness to indicate that this is a readiness check as opposed to a liveliness check. And then I implement the call method that returns a health check response. So that's the only thing I need to implement. And in this case, I create a health check response named greet readiness check. And we see that that's what is reported here on the right. For the state of this readiness check, I'm doing something kind of arbitrary. I'm just checking if the number of available processors is greater than 1. That's kind of a silly thing to do, but it works for the demo. And of course, I'm running on a Linux VM and it has 16 processors. So that satisfies that readiness check. And with the readiness check or any health check, you can add data to it. In this case, we're adding the number of available processors that we see over here. And then we just build and return that. So as you can see, it's very easy in MicroProfile to extend the platform by defining your own health checks, readiness checks, metrics, etc. In this case, I'm just creating a new class and dropping it in. And in our case, the Helidon dev loop detected it, compiled, and restarted the application. All right, and the last thing I wanted to show has to do with application packaging. So I stopped the dev loop above because I want to show that down here. So as I mentioned before, when you build a project by default, you get a very straightforward, simple Java application jar and dependencies. But we also support, as I mentioned in the presentation, some other packaging. In particular, we support JLink, generating a JLink image. So now I'm going to do a rebuild of the project from scratch, but this time I'm telling it to generate a JLink image. And so we provide some tooling that will do this for you, because usually to generate a JLink image of a Java application, all the dependencies have to be well-formed Java modules. And we know that that is not always the case. So our tooling detects dependencies that are not Java modules, and it wraps them into a Java module so that the JDK JLink tooling believes that they are a Java module, and therefore we can generate the JLink image. So as you see, that didn't take too long. And what this is telling us is that initially, if we had the full JDK in our application, it would be 300 megabytes, right? About 290 of that is the JDK. The application is only 18 meg. So that's if there's a full JDK. Running with JLink, that JDK is cut down to a runtime image that only contains what the application needs. So in that case, the JDK went from close to 300 megabytes to 56 megabytes. Again, our application size does not change because that's the same. And then by default, we generate what's called a CDS archive for class data sharing. And what that does, as I mentioned earlier, it creates an on-disk cache of the in-memory representation of Java classes. And in our case, the Helidon tooling kind of takes a snapshot of your application startup, and those are the classes that gets archived in the CDS archive. So that is 62 megabytes. And what the CDS archive does is it gives you a faster startup. So you're trading off some disk space for faster startup. If you don't want to make that trade-off, you can choose to opt out of the CDS archive, at which point you'll save 62 megabytes in disk space. But this little summary anyway gives you an idea about the size of the image that was generated. And again, in this case, that image contains the application, all of the application dependencies, and all of the Java runtime dependencies from the JDK. So it's fully self-contained. And it puts that custom runtime image with your application in a directory, in this case called quickstart mp. And then there is a bin directory, and we have a start script that we generate for you. So this is how you run that custom runtime image containing your application. So again, it starts up as you would expect, just like it did before. And we can, of course, hit our readiness check and see that it is indeed up and running. So that's the JLink custom runtime image packaging. The third packaging we support is the GraalVM native image. So again, I'll do a rebuild of the project, specifying a native image. And this will go through. It first does an ordinary build of the project, and then it will start doing the native image compilation. So it ran the build, and now it is starting to build the native image. So this takes a few minutes for this to complete as it constructs the native image. So instead of waiting for that to finish, I'm going to stop that. And I have one that is pre-built. Trust me, it's the identical application. And in this case, if you look in Target, there is an executable, right? Start MP. So with JLink, that was a directory that contained your JLink image. Here it is a native image. So you'll see I ran file on it. It is indeed a native Linux executable. It was a Java application. Now it's a native executable. And so we can simply run that. And as you can see, the startup there was almost instantaneous. So with the native executable, you get very, very fast startup. And then to prove, oops, don't want to do that. And to prove that it is the same application, we'll hit the Readiness Probe again, and there it is. Okay, so that last part of the demo, I just showed you the 3 packaging options that you can package your Helidon application: a normal, pretty vanilla jar file, a custom, fully self-contained JLink runtime image, or a native image. So we provide all 3 of those packaging formats. And I think with that, my demo is over.